Hello everyone, I'm Dr. K. Today we're going to talk about a topic that seems simple at first glance, but is enough to keep you awake at night. Time. Have you ever wondered whether the atoms in your body actually age? The answer is, they don't. Yes, you heard that right. These atoms were born in stars, drifted through space for billions of years, and eventually became part of you. And yet today, they remain intact, unchanged. Here's the paradox. While you grow older, your memories fade and time relentlessly marches on. These atoms seem never to have experienced it. This raises a staggering possibility. Time might not be a fundamental law of the universe at all, but rather an illusion created by our consciousness. How can this be? If time is just an illusion, what does that mean? Could the chains we've always thought were unbreakable actually be nothing more than constructs of our minds? If time can be manipulated, if it's merely a byproduct of deeper laws, then our perception of reality might be completely upended. Is time real only because we perceive it? Or does the universe itself enforce its flow, trapping us and everything else within it? Over the next few minutes, we'll embark on this journey together, exploring the strange behavior of time in the quantum world, confronting paradoxes at the edge of understanding, and grappling with a question that has haunted humanity for centuries. Are we trapped in time? Or is time itself the ultimate illusion? Let's start with the time we think we know. For centuries, humans believed time was unshakable. Day follows night, seasons change, stars trace fixed paths across the sky. Ancient Greek philosophers considered time the foundation of the universe. Then came the 20th century, and Einstein. He told us that absolute time is an illusion. Relativity showed us that time is flexible, woven together with space to form the reality we experience. Time can slow down, speed up, stretch, and compress. The closer you are to a gravitational source, the slower time flows. The faster you move, the more time stretches. Imagine a pair of twins. One stays on Earth, the other travels in a spaceship near the speed of light. Decades later, the twin on the ship may have aged only a few years, while the one on Earth has grown old and grey. This means that time is different for everyone. It is relative, not absolute, but that's just the beginning. Quantum mechanics tells us that at the microscopic level, time might not exist at all. Electrons don't orbit like planets around a star. They exist in a cloud of probability, both here and there until observed. Even more astonishing, the double-slit experiment shows that a particle's behavior can be influenced by future choices, as if the future is shaping the past. This forces us to question, is the past and future really so clear-cut? If time can be bent, stretched, or rewritten, what exactly are atoms experiencing? Or do they exist on a level beyond time entirely? Quantum entanglement is even more unsettling. Two particles entangled with each other respond instantly, no matter how far apart they are, even across light years. This communication is faster than light, seemingly breaking the limits of time. Some scientists speculate that entanglement might hold the key to understanding time itself. Consider decay. Atoms can decay, like radioactive elements, eventually breaking down into more stable particles. But when a single atom will decay is entirely probabilistic. It could happen next second, or it could wait billions of years. This implies that at the microscopic level, time has no fixed clock. It exists only as probability. Yet in the macroscopic world, we are certain time flows forward. We age, watch clocks tick, remember the past, and can never remember the future. So if atoms don't truly experience time, where does our sense of it come from? Is time merely an emergent phenomenon, existing only on a larger scale? Black holes, neutron stars, even the farthest galaxies at the edge of the universe, all reveal the limits of time. At a black hole's edge, time nearly stops, while the outside world races ahead. And the atoms within you, they still exist, unchanged, unaffected by the passage of time. On the surface of neutron stars, time dilates, moving far slower than the average cosmic flow, and yet atoms remain seemingly immune. What about distant galaxies moving faster than light away from us? How does time flow there? What is time? An actual force or a construct of observation? Entropy gives time its direction. Broken glass doesn't spontaneously reassemble. Heat flows from hot to cold. But at the atomic level, physics allows time to reverse. In the quantum world, particles interact without requiring a one-way flow of time. Then why must we march forward along a single timeline? One explanation is that the universe began in a state of extremely low entropy. From that moment, entropy increased, creating the arrow of time. But why did the universe begin in low entropy? If it started chaotic, how did stars, planets, and life form? Perhaps time is simply a byproduct of entropy, a phenomenon that only emerges on a macroscopic scale. Going even further, if we could manipulate atomic arrangements on the quantum level, reversing their motion, could time flow backward? Some theories suggest that inside black holes, regions of time reversal may exist. But why have we never observed it? The answer may lie in probability. Even if time reversal is possible, the chance of it happening is extremely low. Quantum mechanics also suggests that the future might influence the present. The absorber theory proposes that electron motion can be affected not only by the past, but also by future events. Combined with entanglement, we are forced to wonder, does time truly exist as we imagine? Are past, present, and future merely illusions created by human consciousness? On a macroscopic level, entropy drives time's one-way flow. But in the farthest, coldest reaches of space, where entropy is near zero, could time behave differently? Atoms may transcend time, but what about us? Neuroscience offers clues. Fear makes time slow. Deep meditation can make time seem to vanish. Near-death experiences report a sense of stepping outside time. Could science and mysticism be pointing to the same truth? Time might very well be an illusion. If that's true, life and death take on entirely new meanings. Death may not be an end, but a new form of experience, free from the constraints of time. Our sense of time is merely a tool our brain constructs to comprehend reality. Quantum mechanics and relativity even hint that time travel may not be fantasy. Entanglement, quantum erasure experiments, and closed time-like curves in general relativity all suggest the possibility of transcending temporal limits. The key is not traveling to the past, but entering the timeless state that atoms have always inhabited. The many worlds interpretation offers another perspective. Every quantum event produces all possible outcomes, distributed across countless universes. We perceive only one branch, while atoms may exist across infinite realities. The future is not a single path, but a branching tree of possibilities. The macroscopic world is locked by entropy, time moving forward. At the microscopic level, atoms may transcend time. Could we, like atoms, experience all moments simultaneously existing in past and future at once? If so, humanity's understanding of reality would be fundamentally transformed. The fate of the universe is just as strange. Big crunch, big freeze, big rip, each challenges our ultimate concept of time. Yet atoms persist, indifferent to temporal passage. Are they participating in time, or are they part of a realm beyond it? The holographic principle suggests that our three-dimensional world may be a projection of a deeper reality. Time, space, even reality itself may be surface phenomena. Atoms transcending time might hold the key to understanding the essence of existence. And humanity? Our consciousness is bound by time, but perhaps one day we too could transcend it, like atoms, and see the universe in its full truth. Perhaps we could alter our perception of time and experience past, present, and future simultaneously.